So x equals to y if y is positive. So this is my positive y. So whenever y is positive, the line is x equals to y. So it would look like this. Okay. And x equals to minus y if y is negative. So that is how it will. So this is the negative y territory. So in the negative y territory, the line will be y equals to minus x. So y equals to minus x line looks like this. So this is going to be the x equals to mod y thing. Now, what I have to draw is x minus 2 equals to y minus 3. Okay. So x minus 2 equals to y minus 3 means what? So going in this similar format, I can write the curve of this thing. So x minus 2 equals to mod of y minus 3. So if mod of y minus 3, if y minus 3 is positive, if y minus 3 is positive, then mod of y minus 3 will be just y minus 3. So this will just look like x minus 2 equals to y minus 3, which is basically x equals to y minus 1. So that will be the curve for y minus 3 greater than 0. And what is y minus 3 greater than 0? It's basically y greater than 3. So this is, let's say, y equals to 3. So whenever y is greater than 3, the curve is x equals to y minus 1. Okay. So this is one part. The other part of this is going to be when y is less than 3. Okay, so the second part is if y minus 3 is less than 0. So when y minus 3 is less than 0, the right hand side, which is inside the mod, it becomes negative. So what will we get is x minus 2 will be equal to negative of y minus 3, which is basically 3 minus y. So the curve becomes x plus y is equals to 5, or you can write this y equals to 5 minus x, or basically minus 1 times x plus 5. And this you can write as y equals to x plus 1. So these are your two curves. So remember y equals to mx plus c. So that was the standard format of any curve I told you about, y equals to mx plus c. So I have broken down both these equations in y equals to mx plus c format so that we can now draw them easily. So the slope of this thing is 1, whereas the slope of this thing is minus 1. Okay. Now this thing happens when y is greater than 3. So where is y equal to 3? So this is my y equals to 3. So when y is greater than 3, I will have the curve y equals to x plus 1. So what does y equals to x plus 1 look like? So y equals to x plus 1 is nothing but y equals to x would look like this. So it would be 1 unit above that. So it will look like this. This will be a y equals to x plus 1 curve. Okay. And y equals to minus x plus 5. So what is y equals to minus x plus 5? Y equals to minus x, it looks like this. So y equals to minus x plus 5 will be 5 units above this curve. So this will be just horizontally dragging this curve 5 units up. So it would look like this probably. Okay, so this is your y equals to minus x plus 5. This is line. Okay. Now this line is valid when y is greater than 3. And this line is valid when y is less than 3. So what you actually have is just the right parts of these lines. So the final curve is going to be this one, this, and this. This is your final result. So you can just remove everything else, and this is your final curve. Y above y equals to 3, you have this curve. Below y equals to 3, you have this curve. Now I want to compare this curve with this curve. What is this point going to be? Can anybody tell me this point? the vertex point?
2,
2
and
comma
3.
3. Yeah, y is 3, 2, x will be 2. How do I get x equals to 2? Either you put y equals to 3 here, or you put y equals to 3 here. So if you put y equals to 3 here, x should be equal to 2 to satisfy this equation. If you put y equals to 3 here, again 3 equals to minus x plus 5. So x must be equals to 5 minus 3. So that is equals to 2. So this point is 2 comma 3. All right. Now this point is 2 comma 3. This point was 0 comma 0. So what I'm comparing here really is, I'm giving you a shortcut to draw these curves. So I'm giving, I'm saying that the x equals to mod y curve, it looks like this. So x minus 2 equals to mod of y minus 3 is nothing but this similar V-shaped thing. I don't know. How do you see this? I don't know. There's this mirror image effect because of which I don't know. But yeah, it would be like V-shaped. But the vertex of x equals to mod y was at 0, 0. The vertex of x minus 2 equals to mod y minus 3 was at 2 comma 3. Okay. So this 2 and 3, it's really coming from these values 2 and 3. So now I can draw any random curve without much ado. So if I just give you a curve y minus alpha equals to mod of x minus beta, you will just say that on the Cartesian plane, it would be a V-shaped thing with the vertex at the point alpha comma beta. Whatever this alpha beta is, it could be in any of the quadrants depending on if alpha is negative or beta is negative. So it could be anywhere, but from that point, it would be a V-shaped thing. And by similar logic, if you have x minus gamma equals to mod of y minus delta, it would now be a V-shaped thing, a vertical V-shaped thing from the point gamma comma delta. Okay, so this thing helps. All right, so the entire derivation is important because I would not like you as students right now to just remember the final result. I give you the final result because it helps in exam. It saves time. But when you are doing problems like this, try to get to the result. Don't just jump to directly using formulas. So that would keep your basics strong. Okay, so that takes care of question number 8. Next out.
So in 9th and 10th, my answers weren't matching. Like they
Okay,
had easy questions, but the answers weren't matching.
maybe they are wrong. I don't correct them because that's how I know that students are doing it. Anuradha, I'll come back to you. Mod of x plus 4 is less than 7. Okay, so mod of x plus 4 is less than 7 can be represented as minus 7 less than x plus 4 less than 7. And then you can take this 4 on both sides. So minus 7 minus 4 less than x less than 7 minus 4. Okay, so it just becomes minus 11 less than x less than 3. So minus 11 and 3 are going to be A. Okay. Similarly, mod 3x plus 7 less than 5. So this can be written as minus 5 less than 3x plus 7 less than 5. So then you can take the 7 on both sides. So this becomes minus 12 less than 3x less than 7 goes here minus 2. So then divide by 3. So minus 4 less than x less than minus 2 by 3. Yes, Anuradha.
Yes, I'm getting the same answers.
Okay, great. Anuradha, you had a doubt. You raised a hand. Okay, cool. Any other doubts?
So question number 11.
11th. X square minus 9 equals to x square minus 5. Find all x which satisfy x square minus 9 equals to x square minus 5. Okay. So one thing is when both of them are positive. Okay, when this thing is positive and this thing is positive, think inside the mod. Okay, so if I am generally solving mod f of x equal to mod g of x, I could be in two possible worlds. One world is where f of x equals to g of x. The other world could be where f of x equals to minus g of x. Okay. The other possible worlds are basically minus f of x equals to minus g of x, which is basically the same as this thing. So they are not different cases. Another thing would be minus f of x equals to g of x. And these two cases are different. So really, there are just two different possibilities, that f of x and g of x are both same, or they are just negative inverses of each other. Okay, so these are the only two possibilities, in which case the mod of both f of x and g of x would be same. All right. So what I do now is I take these two cases, I remove the red cases because they are just the image and the mirror of these two actual cases. So f of x equals to g of x, the case one. So in case one, what happens is I'll get basically x square minus 9 equals to x square minus 5. X square cancels out. So what you'll get is minus 9 equals to minus 5, which is not possible. It's a contradiction. So this thing can never happen. Now let's look at case 2. So case 2 would be x square minus 9 equals to minus of x square minus 5. So now when I rearrange them, what I get is twice of x square is equal to 9 comes on this side. So 9 plus 5. So that is equal to 14, which implies that x square equals to 7, which implies that x equals to plus minus under root of 7. Okay, so these are your two options. So x equals to plus root 7, x equals to minus root 7. That are going to be your answer. Plus root 7. And like I said, root 7 is always positive. So that's why root 7 is not plus minus in itself. Root 7 is always positive root of 7. So this is the positive root of 7, and this, because you put a negative sign in front of it, this becomes the negative root of 7. All right, next up. Okay, if you have any other doubts, maybe you have a go at it again and you ask me on the chat. Then more than the stipulated time I had for doubts, because I also want to wrap up the next chapter so that I can give you more problem sets. Let me do the problems and then we can come to the test. Okay, sorry, let me do the sets thing and then we can come to the test which I had shared. So as you can see, I guess you guys would have explored. I'm going to proceed in this manner in math, in real analysis. All right, so it's going to be in this manner. So this is going to be the sequence in which we are going to read things. So if you want to go ahead of yourself, if you have time on your hands, you want to go ahead of me, so you can proceed in this manner. Ananya, question 15. Let me have a look at the solution. I'll share, update it if required. Okay. We just do sets and functions today, so that I can give you some more problems after today's class. Okay, sets. So what are sets? So sets, if an element X is in a set A, sets are basically collection of objects, right? So generally we use the word set when we talk about, let's say, a jewelry set. So a jewelry set is really a set of a couple of earrings, a necklace, and stuff. So sets are basically collection of any object. You could have a set of trousers, a set of shirts, anything is possible. Now, when some element X is in a set, we represent it as X belongs to A. So this is, let's say, some set A, and X is a member of this set. So X belongs to A is going to be the way we write it. Now, uh, let's say A is the set of doctors, and X is, let's say, Dr. Mishra, somebody. So we can write that X, that is Dr. Mishra, is an element of the set of doctors. Okay, so we say X is a member of A, or that X belongs to A. Now, if X is not in A, so let's say some other guy Y, he's not a doctor, so he's an architect. So this Y does not belong to A, so we write it like this. So these are the symbols. Now subsets. So if every element of set A also belongs to set B, we say that A is a subset of B. Okay, so let's say B is the all graduates, all educated people. Educated, okay? Educated is different from literate. Literate is just being able to read and write. Educated is you have got some formal education. So these are all educated people, and so we say that A is a subset of B. A was a set of doctors, so we can say that A is this thing. Now, this thing means that either A is um, something which is a set. So this could be set B, and this could be set A. So in this case, we say A is proper subset. And if A and B are both same, in that case, we say A equal to. Okay. So if we are not sure which of these two conditions hold, we generally like it at this. So either of these things could be true. So this is logically equivalent to A subset B or A equal to B. Okay, so this is logical. These are two logically equivalent statements. The reverse is B is superset. So we say this as A is subset of B, and this is B is superset of A. Okay, subset, superset. Okay, like we say subscript, superscript by similar logic. Now, two sets A and B are said to be equal. What does it mean for two sets to be equal? They are equal if they contain the same elements. So they should have exactly the same elements. To prove that two sets are equal, we must show that A is a subset of B and B is a subset of A. Right? So if we show both these things simultaneously, we have basically shown that both A and B are subsets of each other, so they both must be equal. All right. Now, set is normally defined by either listing its element explicitly or by specifying a property that determines the elements of the set. So suppose I want to define a set. So how can I write the set? So I can basically include in each and every element separately. So let's say I just want to include the set of shirts that I have. So there's this yellow shirt I have, there's a brown shirt I have, there's a black shirt I have, there's a white shirt I have. So these are the four elements, end of story. So this is one way to represent set. Another way would be to represent sets in form of some function. So an example of that would be all the squares, the list of all squares, the set of all squares. So it could be represented in this format. The set of all squares is n square, where n belongs to natural numbers. Okay, natural numbers is a generally defined set. So these are some popular sets. Natural numbers, all positive integers. These are going to be called as our natural numbers. Okay. Integers, we know that is represented by Z. What you need to remember is that N means natural numbers, Z means integers, Q means rational numbers, and R means real numbers. Okay, so you need to remember these symbols. So that's important because A lot of times you will just see in questions, examiner or question mentioning these symbols and not clarifying what it means. So you should remember these are standard notations. Okay, every book everywhere will represent integers as z's. Everything with everywhere you see rational number, the set of rational numbers being represented as q. So there's no ambiguity here. So you should also be clear in your mind. A set of even numbers is E, that is 2k for all natural numbers. The set of odd numbers is 2k minus 1 for all natural numbers. So that's even and odd numbers. The next is power sets. So power set of any set X is a set of all subsets of X. So suppose X is the set of all shirts that I have. Suppose shirt 1, shirt 2, shirt 3, shirt 4. So I have 4 shirts. And this is the set of all the shirts that I have. Now, suppose I have decided to go to a trip to go. Okay. Now I'm deciding which of these 4 shirts to take. So my possibilities, what are all possibilities of combinations of shirts that I can take to go? So that is a power set of X. So I could either take no set, so that will be null set. This is like I just go there bare shirt. Like Goa hai garmi hogi kya karunga shirt ka, okay? So that is a possibility. Another possibility is I carry only shirt 1. Okay, another possibility I carry only shirt 2. Another possibility only shirt 3. Another possibility only shirt 4. Another possibility is I carry 2 shirts, shirt 1, shirt 2, and so on. Okay, another possibility I carry 3 shirts. Last possibility is I carry all the shirts. So all the different possibilities for me to pack my luggage in, they all represent the power set of X. So power set of X is the set of all subsets of X. So if X is just 1, 2, 3, the power set of X will be null set. This is called 5, which is null set. Then only 1, only 2, only 3. So I cannot write this as 1. Okay. So the difference between 1 and 1 is this is element 1. This is a set which contains only element 1. So when I'm carrying a shirt, I can just wear a shirt and take it. So that becomes just element 1. But I can take this shirt, put it in a suitcase and take it with me in the plane. So that becomes the set which has only one element. The suitcase becomes the set and it has only one element, only one shirt in it. So that is the difference between 1 and bracket. So bracket 1 is a set, 1 is an element. Okay, it's the difference between a shirt and a shirt in a bag. If you put shirt in a bag, it becomes a set, everything in it. Now it does not matter if that set has only one element in it, it will be called a singleton set. But 1 and bracket 1 are different things. Okay. All right. So we have already seen the set of natural numbers is basically 1, 2, 3, 4, and so on. So the power set of natural numbers will basically be the set null set, then only 1, only 2, and so on. Then only 1 and 2, only 2 and 3, and so on. Then only 1, 2, and 3, and so on. Then 4 elements, 5 elements, 6 elements. So it will be infinite. In general, if any set has k elements in it, then power set of X will have 2 to the power k elements. So this is a simple what do you call permutation and combination question, that if X has k elements in it, then in any power set, when you're building any power set, each element has 2 options, either to be in the power set, to be in the subset or not be in the subset. Okay, so each of the k elements has 2 options, so you're basically multiplying 2 k times, so that becomes 2 to the power k. So you will have 2 to the power k elements in the power set of any set that has k elements. Okay. So with that in mind about power set and everything, just tell me which of the following statements is false. Okay, take your time, take a couple of minutes and tell me. Okay, so be wary of these symbols. Okay, this is subset, this is belongs to. So epsilon and belongs to are different things. So tell me which of these statements is false. Everybody just type your answers. That would be easier for me to remember. I can just go through the answers. So once you've gone through this, just type your answers so that I can compare.
Sir,
Yeah.
sir, I have doubt that in F, E and F, why there's a double braces?
I'll clarify it. We'll clarify it. So the double braces are basically coming from the fact that uh, so this is basically a subset of n, right? This is a subset of n. One is bracket one is a subset of n. Now, because bracket one is a subset of n, bracket one becomes an element of power set of n. Now you can call bracket one as, let's say, t. So t is an element of, and let me call this set as b. Set as b. So t is an element of b. So if anything is an element of b, then bracket t should be a subset of b. By the same logic that if one was an element of n, then bracket one became a subset of n. So if element t was an element of set b, then bracket t must be a subset of b. Now what is b? B is nothing but power set of n, and bracket t is bracket of bracket one. So bracket one is a element in n, so bracket of bracket one becomes a subset of power set of n. So these power sets, they are sort of, inductive things. So there's a n, there's power set of n, then there's power set of power set of n, then there could be power set of power set of power set of n, and so on. It goes on. Okay, you can build an infinite tree like that. All right, so by that logic, I've also answered this question in itself. So one is an element of n, so that I know is true. So by that logic, bracket one will be a subset of n. So this is false. Now bracket one, because it's a subset of n, power set of n is just it contains all the subsets of n. Okay, so since bracket 1 is a subset of n, it should be an element of power set of n. Now, since it is an element of power set of n, bracket of bracket 1 should be a subset of power set of n. Okay, and this becomes false. So B and E are false. So some of you gave the correct answer. I guess Ananya gave the correct answer, and Kanishka and Ananya gave the correct answers. So that's the idea. So these are really just things which you can keep building on one upon the other, power set to power set, and so on. But generally in our discussions will not go beyond one power. Okay, we'll mostly talk about the one power of any set. Now this becomes a very important topic when you do topology. So like I said, for any finite set with n elements, 2 to the power, the power set will have 2 to the power n elements, because each element has two options, either to be or not be in the subset. So each element gets two options. So two options multiplied by number of elements, 2 to the power n. So the power set of any set x, the power set of any set x is sometimes referred to as 2 to the power x. So there will be this topic called topology at your master's level. It becomes a very important topic if you want to pursue research. So in topology, you will do a lot of these things, power sets and everything. So maybe if one of you goes to study topology, maybe this entire discussion in power set you will be doing in much more detail. All right, now set operations. So you might know about these set operations, so I will not talk in much detail. Union of sets. So if you have two sets A and B, which look like this, let's say this is set A and this is, let's say, set B. Set A and set B. So this really is your A intersection B, and this is your A intersection B, and this entire thing is your A union. So A union B can be defined in set format as all elements X such that you can write this as, in words, you can write this as A union B is the set of all elements X such that X belongs to A or X belongs to B. So that's the logical way to write A union B set. So it is a collection of all elements which are either a member of party A or member of party B. Okay, so so that's A union B. Now intersection is basically all elements X such that A belongs to A and A belongs to B. So the only difference between union and intersection is here. So OR means union and means intersection. So that's the only difference. Now the complement of B with respect to A, how is that defined? So A complement B. So this is represented as A complement B. So this is basically also written as A set minus B. This does not work like minus when it comes to numbers. Okay, so I know that 5 minus 4 is equal to 1. So this is subtraction of numbers. This is not subtraction of numbers. Now what I'm doing is subtraction of sets. Okay, so A set minus B is all the elements in A which do not belong to B. Okay. So suppose you are you are basically administering some medicine to people in set A, but you don't want to administer it to people who are diabetic. So suppose A is all the elderly people, but you are not sure about the medicine's impact on diabetic people. So you don't want to give it to diabetic people. So what you happens is you take into consideration all the people who are elderly, that is above 60, but who are non-diabetic. Okay. So what it looks like, what does this set look like in set theory? So let me call this as, for your benefit, let me call this as, let's say, region 1. Let me call this middle part as region 2 and the right part as region 3. Okay, so these are my 3 regions. Yeah, region 1, region 2, and region 3. Okay, this was my set A and this was my set B. So in terms of regions, what region or combination of regions would represent A set minus B?
So 1.
Very good. Okay, so it would be 1, just region 1. So what happens is you take the entire set A and you remove the elements in set A which belong to set B. So it's going to be just region 1. What about B minus A?
So 3.
Very good. It will be just region 3. Okay, so A minus B is region 1 and B minus A is region 3. So these are separate regions. So how is set minus different from A union B and B union A? Is that even though A union B is equal to B union A and A intersection B is also equal to B intersection A, but A set minus B is not equal to B set minus A. These two things are not equal. Okay, so that's the only difference between these things. So this is another graphical representation of the same thing. Now, in general, you can also talk about complements of a set. So a complement, this is just the entire field minus set A. So when I give you a complement, you need to first know what the field is. Okay, what does it mean that you need to know the field? So to give you an example, suppose I give you that set A is just number 1. And then I ask you, what is A complement? Now, to answer this, you need to know what is this set A a part of. Does this set A come from the set of real numbers? Or does it come from the set of integers? Or does it come from the set of natural numbers? Because if it comes from the field of real numbers, then A complement would be negative infinity to 1 union 1 to infinity. If it comes from the field of all integers, Z complement would be basically 0, minus 1, plus minus 2, plus minus 3, and so on. So that would be A complement. And if it comes from the field of natural numbers, then A complement would be all the natural numbers except 1. So 2, 3, 4, and so on. So to answer the question A complement, if I just give you A, would require you to first know what is the field. Now, in general, for us, the field is going to be pretty obvious because we are economists. Like I told you, when you talk about prices, okay, so for prices, the field is R plus, okay, R plus plus actually, which is basically 0 to infinity. And for quantity, the field is R plus, which is open 0 to infinity. So suppose, for example, you are considering a firm which manufactures a quantity Q which is less than or equal to 20 and sells at a price P less than equals to 100. So suppose there's some price ceiling and there's some quantity constraint. So what is the set of all possible quantities now? So greater than 20 is not allowed. Quantity greater than 20 is not allowed. So because I know the field, I know what will be the set of quantities now. Set of possible quantities.
So closed interval from 0 to 20.
Okay, great. And 20 पे भी closed है. All right. And so it's closed at both sides. What about the set of possible prices?
Sir, open interval from 0 to 100 and closed on 100.
Very good. Okay, so that's how you define it. That's how you can find the possible prices and quantities, because you know these things in the back of your brain. You know this thing happens. All right. So these things are very you can say non-important, like, but they might become important in some situations. Okay, so so the point I'm making is that because you know the context, because you know that what field you're talking about whenever you're dealing with different variables, because you know it in the back of your hand, you can say these things. But if you were not sure, if a simple mathematician were asked if quantity less than equals to 20 is allowed, what is the set of allowed values for Q? A mathematician would say that the allowed values for Q are negative infinity to 20. Okay, but since we are economists, we know that Q being a quantity has to be greater than equals to 0. Okay, so that's the difference which knowing the field makes. All right, so then I have a two sets, so you have to find different values. So I'm just leaving it to you guys to do it. It's not very complicated. I have also given the field as set of natural numbers. It's really very easy. So I don't know why I even have it here. Then we talk about De Morgan's laws. So we talked about De Morgan's laws in the case of logic. So we said negation of A and B is basically negation of, let's say, statements P and Q was negation P or negation Q. Okay. Now, De Morgan's laws is A union B complement. What is A union B complement? A union B complement means A union B is A, set A or set B, and complement is nothing but negation. Complement means not in A union B. So not in A union B means negation of A or negation of B, which will basically be negation A and negation B. Now negation A is nothing but A complement and negation B is nothing but B complement, and becomes intersection. So these two De Morgan's laws are really related. So the De Morgan's laws of logic and set is the same thing. That's why it's the same deal. It's called De Morgan's laws. So it's not De Morgan gave two different laws, one for set theory and one for logic. Because these two things are related. Logic is what defines sets. Sets are defined by logic. So the rules which apply on logic eventually apply on sets. So let's do an example of some proof. So A, B, and C are sets. So we have to show that A set minus B union C must be equal to A set minus B intersection A set minus C. So this is what we have to show. So I have to show that the theorem is A set minus B union C is equal to A set minus B intersection A set minus C. Okay. So how do we show these things? So maybe you get a question like this in your ISI subjective part. So how do you approach it? So the way to approach this is you call this as set P and you call this as set Q. So first part would be to show P is a subset of Q. The second part would be to show that Q is a subset of P. And when you have done both these parts simultaneously imply that P and Q are equal sets. So that's what I have to show, an equality between these two sets. Okay, so you can prove any of these parts first. So we'll prove this in two parts. So first we show that P is a subset of Q. So how do you show this? P is a subset of Q. So P subset Q implies that if X belongs to P, then X belongs to Q. P is a subset of Q means what? This is the set Q and this is the set P. So if any element lies in P, it should lie in Q, right? Q is the larger of the two sets. So I'm going to proceed in a manner where I show that I take some arbitrary point which belongs to this set, and then I show that it belongs to this set. And in the second part, I'm going to start with the arbitrary point in this set Q, and then I'm going to show that because it lies in Q, it also lies in P, and then the proof will be complete. So let us do the first part. We start by taking an element which belongs to A set minus B union C. So X belongs to A set minus B union C, right? So X is in A set minus B union C, then X is in A, but X is not in B union C, right? So what this means is that X belongs to A and X does not belong to B union C, right? A set minus B union C means it remains in A, but it is not included in B union C. Because if it were present in B union C, then it would have been eliminated when you did A set minus B union C, right? So this means what? That X belongs to A and X does not belong to B and X does not belong to C. Because if it does not belong to B union C, okay, it means that it should not be in B and it should not be in C. This and kahan and aayega, kahan aur aayega, that is the key. Okay, so it should not belong to B and it should not belong to C. Okay, just focus on this part. What am I meaning by this? What do I mean here? So suppose you have two sets B and C. Okay, so suppose these are your two sets B and C. So I'm saying X does not belong to B union C. B union C is this entire thing. So it means that X belongs somewhere here. So it does not belong to B and it does not belong to C. Okay, so this says that B and C dono ka bhi part nahi hai. It's not a part of either of them. So it belongs to A, but it does not belong to B and C. So if my set A were something like this, if this were my set A, then X probably lies somewhere here. It cannot lie here or here or here because then X would be eliminated. It cannot lie here because then X would not be a part of A either. So it has to be in basically this region. This is the possible region for X. So X belongs to A and it does not belong to B and it does not belong to C. Okay. Now I can open it up. I can open this bracket up. So I can write X belongs to A and X does not belong to B. Yeah, and X belongs to A and X does not belong to C. So that's how I can open this bracket up. So that's how this bracket opening opens. So this X belongs to A and it splits over both these things. Okay, so it would split with this and it would split with this. Okay, so X belongs to A and X not belongs to B. This just implies that X belongs to A set minus B and X belongs to A set minus C. Now this is the definition of A set minus C. This is the definition of A set minus B. So it belongs to both these things. So X just belongs to A set minus B intersection A set minus C. Okay, so it belongs to A set minus B and it belongs to A set minus C. So it belongs to the intersection of these two sets because it belongs to both these sets simultaneously. So this is how you proceed in a question like this. The reverse part is proved here. So X belongs to both these sets. So it belongs to A set minus B and it belongs to A set minus C. So again, I start from here. So I'll proceed in the reverse direction. So X belongs to this. So if X belongs to this, I can split this up. It belongs to A set minus B and it belongs to A set minus C. So after that, I can write it like this. And then I can write it like this. And then I can write it like this. And finally, this leads to this. So in the first part, I go from here to here. In the second part, I go in the opposite direction. So this is simple proof. Sometimes it might not be just the reverse. Sometimes you'll have to take some trajectory going in one direction. In another direction, you might have to build a separate trajectory altogether. But the important thing is that you need to go the forward and the reverse directions. In both way, you have to prove the subset thing. And when you have done it, you have basically shown that both the sets are equal. So the final thing is that these two sets, which we call as set P and set Q, they are rendered equal. And that's what we wanted to show, that these two sets, they should be equal to each other. Okay. So I'm giving you a similar proof as homework. A set minus B intersection C should be equal to A set minus B union A set minus C. Okay. So that's your homework. So we'll discuss it in the next class. Just remind me to discuss it with you guys. Right, so try your hand at it, and I can take doubts. If you follow some other trajectory to do it, we can discuss it tomorrow. Not tomorrow, sorry, in the next class. Next thing is collection of sets. So collection of sets is just so let's say I have a set of shorts. Then I have a set of trousers. So when I'm packing for Goa, I have a set of shirts, shirt 1, shirt 2, shirt 3. I have a trouser 1, trouser 2, trouser 3. And I want to pick which shirts and which trousers I'm taking to Goa. Okay, so the everything that I actually pack will be a collection of shirts and collection of trousers. So suppose I decide to pack everything, all the shirts, all the trousers. So let's say this is set S and this is set T. Okay, so the suitcase that I pack for Goa will be set S union set T. So that is going to be a collection of sets, a union of collection of sets. Okay. All right. Now, next is that intersection. So intersection is there are two different sets and you take the intersection. So shorts trousers is not a good example because S intersection T will always be a null set because shorts and trousers are different things. But you can talk about numbers. So S is, let's say, odd numbers. Sorry, O is, let's say, odd numbers and P is, let's say, prime numbers. So O intersection P will be the set, basically 2 will not be included. 2 is prime but not odd. 3 is odd and prime. 5 is odd and prime. 7 is odd and prime. 11, 13, 17, 19. So, and so on. So these will be all odd prime numbers. In fact, barring 2, all the numbers are odd prime numbers. Okay. So that's intersection of two things. Now, suppose you take intersection of multiple sets like this. Okay, so suppose there's a set of odd numbers, there's a set of prime numbers, and there's a set of numbers divisible by 5, numbers divisible by 100, and so on. So you could have n different sets. Okay, so union of C is just the union of each of these sets. So when you have more than 2 sets, you can either write it as C1 union C2 union C3 union C4 and so on, which becomes very cumbersome. So another way to write it would be just union of Ci for all I belonging to, let's say, natural numbers. Suppose this is an infinite collection. So one way to write it, just union of all CI. So it's just representational thing. So you can write it as each and every set separately, or you can just write like bada U likh ke UCI. Suppose G equals to, so this example is that suppose G is a set of all students in a group, and for any student I, G, I have any student I in this class, MI represent the set of movies that a student is. So we see that in this class, I have like 11 students right now. So suppose I ask you all to enlist all the movies that you have seen. Well, that would be a very long list. So let's stick with books, because people generally read less books than watch movies. So if I just ask each of you students, so suppose the first student I ask gives me a set of movies B11, B12, B13, and so on. The books which second student has read. So let's say second student has read Lord of the Rings trilogy and Godfather trilogy. Okay. Book which students one has read is, let's say, she's read The Alchemist and Pride and Prejudice. Okay, student 3 has, let's say, read, and this guy has also read, say, Godfather. Student 3 has read Godfather and one more book, let's say, Huckleberry Finn. Okay, so these are the only 3 students, let's say, I study. So intersection BI is basically B1 intersection B2 intersection B3. So that will be the intersection. The intersection here has just Godfather in it. Whereas union BI would be the sum of all the elements. So it will be Alchemist, Pride and Prejudice, Godfather, LOTR, Huckleberry Finn. Okay, so these are the different books that will be included in the union BI. So instead of writing B1 union B2 union B3, what I do is just union of all BI values. So that's just notational thing. It's nothing different really. All right, now this collection could even be infinite. All right, so this could go until infinity as well. So suppose we have infinite number of stars, and we want to write the set of planets of each and every star. So star one's planet. So let's say star one is the sun. Sun is a star, right? It is the closest star that we have. So the stars, the planets of sun will be Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So that would be the planets of sun one. Then you star one. Then you could have another star. Let's say I don't know, some other star, Alpha Centauri or whatever. So you write the planets next to that star. So you have infinite number of stars in the galaxy, in the universe. So you have an infinite set if you write down all the planets. So that becomes that. Okay, now Cartesian product. So that's just a representational thing. It's nothing new. It's just that now intersection would apply to intersection of all the different sets. Union would apply to union of all the different sets and so on. So it's just a representational thing. So you can write it like this: intersection of all the sets going from 1 to infinity. So this becomes intersection of these infinite sets. Cartesian product. So Cartesian product is basically represented as x cross y. So this is not multiplication. So I know that 3 cross 4 is 12. This is multiplication of numbers. I'm not talking about multiplication of sets. You cannot multiply sets. What is Cartesian product then? Cartesian product is basically all ordered pairs xy where the first element comes from x and the second element comes from y. So suppose when I travel to Goa, I have carried my shirts as The set of shirts I carry is shirt 1, shirt 2, and shirt 3. And the set of shorts or trousers which I've carried is trouser 1, trouser 2, trouser 3. Now, what is the set of all combinations that I can wear? So the set of all combinations I can wear is S cross T, which is basically all values where the first element comes from this set and the second element comes from this set. So it could be S1, comma T1, or it could be S1, comma T2, or it could be S1, comma T3, right? I should have written less amount of things. That would have been easy. So let me reduce one set. Then S2, comma T1, S2, comma T2, and S2, comma T3. So this is basically all possible combinations of shirts and trousers which I can wear in Goa if I carry these two things. It's another matter if they don't match. Okay. I mean, if you wear a black shirt with a black jeans, your girlfriend is gonna be angry with you. But for a mathematician, it's still a statistical possibility that you can wear it, even if it does not match, doesn't go, it looks funny, you can still wear it. All right, so this is a Cartesian product. Now, T1, comma S1 is not a member. T1, comma member S1 does not belong to the Cartesian product S cross T, because the first element should come from the set of shirts. Here, you cannot wear trouser on top and shirt on bottom. So T1, comma S1 is not a element. Okay, first element shirt, second element trouser. All right. So all such elements are going to be your Cartesian product. So in the first microeconomics class, we talked about consumption sets. So consumption sets are nothing but Cartesian products. So one consumption bundle is, let's say, 2, comma 3. So what is 2, comma 3? 2 units of good X and 3 units of good Y. That is the meaning of 2, comma 3. So the bundle 2, comma 3 means on the X-axis you consume 2 elements, and on the Y-axis you consume 3 elements. So it is this bundle 2, comma 3. So it's a Cartesian product of amount of good X and amount of good Y. So that's the meaning of Cartesian product. Now 2, comma 3 is not equal to 3, comma 2, because in 3, comma 2, 3 is amount of good X and 2 is amount of good Y. Right? So 3, comma 2 is this point. This point is 3, comma 2. Whereas this point is 2, comma 3. So these are different points, 2, comma 3 and 3, comma 2. These are different points. So that's your Cartesian product. Yeah. Okay, so suppose X comes from R plus, like we talked about, quantities can be R plus, and Y is also available in R plus quantities. So the consumption set will basically be X cross Y. Now X is the set R plus, because X can take any real number quantity. So it will be R plus cross R plus. So R plus cross R plus is basically R plus square. That's like saying that N into N is N square. So the feel is similar, but it does not mean that I have multiplied R plus with R plus, right? These are sets. You cannot multiply sets. Here what I'm saying is that good X can be consumed in any real number quantity, and good Y can also be consumed in any real number quantity. Now, had good X and Y been just non-divisible goods. Okay, so example, X and Y are non-divisible goods, which means that X comes from the set Z plus and Y comes from the set Z plus. So in that case, what happens is that your X plus Y, sorry, X cross Y is the set Z plus cross Z plus, which is basically Z plus square. Okay, you can write it as z plus square. You can call it z plus square. It does not mean multiplication, to be frank. It is represented as z plus square, but it's not squaring anything. It's just a Cartesian product. It means that the first element belongs to a positive integer, non-negative integer, and second element belongs to a non-negative integer. So we talked about such cases, right? In the last class, we talked about such cases. So x could be any integer, y could be any integer. So the final set of values could be on the intersection of these lines. So x cross y will be intersection of these lines. So in most cases, what we'll see is in consumer theory, in most cases, you will see the statement that that the consumption vector x belongs to Rn plus. What this means is that x is really a vector, which is basically x1, x2, and till xn, where each of these element represents the quantity of the particular good. So x1 means the amount of good 1, x2 means the amount of good 2, and so on. And each of these things is coming from R plus. So these are some important things which we see but we never notice. So I just want you to know these things because sometimes it is possible that the examiner might play on these things. Okay, sometimes they can ask you in interview, what is this Rn plus? Okay, so you have seen this countless times without even wondering, let's say, or what is Rn plus. This is the meaning of Rn plus. This is just our Cartesian product of R plus n times. Okay, so that is x belonging to Rn plus, and this x is really just x vector. This is the vector of consumption. Okay. Now you can also have the product of the same set with itself. Okay, so suppose you have a set of shirts with you, which is, let's say, shirt 1 and shirt 2, and you're deciding, you're out for a 2-day trip, you're deciding which shirt to wear on different days. Let's say shirt 3 is also there. So the possible values of combinations that you can wear will be shirt on day 1, small s, comma, shirt on day 2, which belongs to the set S cross S. Okay. Small s is shirt worn on day 1. Capital S1 is the first shirt that you have. Let's say blue shirt, green shirt, red shirt, whatever. RBG, let's go with RBG. RGB, red, green, blue. Okay, red, green, blue. So this would have elements like what? S cross S will have elements like S1 comma S1, S1 comma S2, S1 comma S3, and so on. S1 comma S1. What is S1 comma S1? S1 comma S1 is you wear shirt 1 on day 1 and you wear shirt 1 on day 2. Okay, now it is possible that you might not like wearing it, but it is still a mathematical possibility that you can wear the same shirt on both the days. Okay, your personal sense of hygiene might not let you wear the same shirt twice, but then we all happen. We are friend just does that. Okay, he carries a lot of shirt, he has a lot of shirt, but continues to wear the same shirt again and again. So yeah, so shirt 1, shirt 2 is shirt 1 on day 1. Now shirt 2, shirt 1 is also a possibility that you wear shirt 1 on day 1, shirt 2 on day 2. Shirt 2 on day 1 and shirt 1. Shirt 1 on day 2. So you can flip it up and it becomes a different thing. Okay, S1, S2 and S2, S1 are different things. Okay, so that's a Cartesian product of a set with itself. So that is another possibility. You can take the Cartesian product of set with itself. You can take Cartesian product of two different sets. All right, now with that idea of Cartesian products, I want to move to functions. So what are functions? So functions, really, we have been given functions as that this is domain, which we call as X, and there's this set Y, which is called as codomain. And function is just mapping of elements. So there's some element X here. In the functional mapping, it gives you an element f of X. Okay. So a functional mapping could be, let's say, a very simple thing like your age. So age is a function. I input your name, I get age as an outcome. For example, I don't know if you have used this Covin app, but if you input your Aadhaar card number, it automatically captures your age. Okay, so it's used as a functional thing. What's the function which Aadhaar card is? You have never told Aadhaar authorities your age. You're given your date of birth. From the date of birth, they calculate your age. Okay, so let's say somebody had their 18th birthday today. Till yesterday, they were not eligible for a vaccine, but since they became 18 years old today they are eligible for a vaccine. So it's a very dynamic function. Okay, so that's one example of a function. Another example of a function would be uh, your mother. Okay, so Aadhaar card can also tell you who's your mother because you give that information to Aadhaar. Okay, so if you input that thing, it can find out who your mother is, who your father is, and everything. So, so that's the idea of Aadhaar. So you get all kinds of links available there. Okay, so that's the actual the starting point of any function is called the domain. The end point is called a codomain. The function is represented as f x to f of x. So this is one way to write it. Another way to write it is function f defined from set x to set y. Okay. One important thing to remember is that a function is not a mathematical equation. So whenever I ask people what is a function, so if the function is like x squared, 3x, 2x, that's not a function. A function is a mapping which obeys two very simple properties. That every element in x should be mapped and every element in x should be uniquely mapped. So Aadhaar card, your age, whenever you input some Aadhaar card number, the age associated with that Aadhaar card number should generate a single outcome. Okay, you should not get two different ages, and everybody should have one age. It should not be that somebody has no age at all. That cannot happen. Okay, so so a function on age through Aadhaar card is a function, a relationship. Let me call the general word relationship. So the relationship f, which gives the age of any agent, is a function. So let me ask you a question. Suppose a relationship m of x gives the mother, the biological mother of any person. Okay, will this be will this relationship be a function? There are two things to consider. That basically there's just one thing to consider, that every input must have a unique output. So the question to consider here is, does everybody have a mother? And does everybody have a unique? Like everybody should give one output and nobody should give multiple outputs. So what cannot happen here is that you cannot have a situation which looks like this. Okay, so somebody having two mothers, okay, that's not allowed. Okay, so if you're Christian, says, yeah, I want two mothers, no, you don't get it. Only biological mother counts. All right. The next thing is somebody cannot say that I don't have a mother. I mean, this is plausible, really. I mean, somebody does not know their mother, but I am not accounting for the fact. I'm not asking if you know your mother. I'm saying that if the mother exists or not. So that's the mother function. Even if you don't know it, let's say God inputs that value and tells who the biological mother is. So coming back, is the relationship m of x, which is the biological mother of any person, is this relationship a function or not?
Yes, sir.
It is, yeah, because everybody has a biological mother, even if some people, due to certain circumstances, might not know their biological mother. Everybody has a unique biological mother. Okay. Other is, let's say, uh, grandmother of x. The grandmother of X gives the grandmother of any agent X. Now, will this relationship be a function? You know what a grandmother is, right? So, will this relationship be a function?
So it's like grandmother can be Dada or the
Yeah,
Dadi
it
and
could be
Nani
Dadi or
both.
Nani. So there are two grandmothers. So everybody will have two grandmothers now. One is your paternal grandmother, the other is your maternal grandmother. So there are two options here. So this is not a function. Okay. So that's the idea. So mother relationship is a function, but the relationship of a grandmother is not a function because you have two grandmothers. One on your one's your father's mother, the other is your mother's mother. So there are two grandmothers. Similarly, siblings is not a function. It's a relationship, but not a function because somebody can have multiple siblings. Somebody might not have any siblings at all. Somebody might be a single kid. So these are all examples of relationships. Some of them are functions, some of them are not functions. But important thing to remember is that not everything is just mathematical equation. Not everything is quadratic equations, cubic equations, logarithmic exponential equations. Uh, these things, they happen beyond the realm of math as well. Okay, so this is just pure logic. Okay. So the idea of Aadhaar is entirely this, that what happened is that there was too much of chaos here and there, that people would have different bank accounts, different properties in different names, and everything was too complicated. Now they made it simple. You need to register everything with your Aadhaar card. Okay, so if you register a property, if you have a lot of wealth, you register a property in the name of your wife. The government knows that you are related to your wife, so it's the entire Hindu family which gets accounted for that wealth. So now, if let's say if your father is not working or your grandfather is not working, still he's buying property, then it will raise questions like if he's not earning, how is he getting property? And the government will definitely catch hold of you. So that's the idea of Aadhaar card, that you're trying to link things between people so that such kind of transactions which used to go under the radar, they do not go under the radar. So you can have more tax incidents now. So that's the idea. Important thing for us to remember is that functions are not mathematical equations. That's what I want you to take away, that everything that we are doing goes beyond maths. Okay, so the definition of a function from set A to set B is a set of order pairs A cross B such that for each X belonging to A, there exists a unique Y belonging to B. So there is this set A and there is this set B, and there is some element X here. For every element X here, there is an element Y here, such that Y is equals to F of X. So that's the definition of a function. A function is really just Cartesian product of elements from A and elements from B. So suppose I talk about weight of a person. So weight is a function. So it changes. It's not a fixed function, it changes. When lockdowns happen, it becomes an increasing function for everyone. Everybody's weight increases. So it's not a constant function. It can change depending on your situation, but it is a function because at any point of time, you stand on the scale, it gives you a value. For every person, there's this unique value which it gives. Okay, it could change for every moment, for every time of the day you have, depending on how much you eat. But it would be a constant value for at any given time. Now, what is a vertical line test? A vertical line test for a function is that basically, if you plot a vertical line on the graph of a function, it will hit the graph at most at one point. Okay, so this blue thing, it's a function, right? So if you draw any vertical lines, like this, if you draw any vertical line, it will always hit the graph at most points. Suppose I define something, not necessarily a function, but I define this as y square equals to, or rather x equals to mod y. I know that x equals to mod y looks like this. I just saw this earlier today. So now when you draw a vertical line here, it is hitting this graph twice. So this is x equals to mod y is not a function. This thing is not a function. Okay, x equals to mod y is not a function because vertical line is hitting it twice. Vertical line hitting twice means what? For any x value, you get two outputs. So suppose I give you for any x, you can have two y values. So if I give you that x was 3, then y could have been 3 or y could have been minus 3. Either of the y values could give you this. So this green graph is not a function. Okay. Now y equals to x squared. Y equals to x squared, it looks like this. So again, this is a function because you see all the vertical lines, they are hitting it at max once. But x equals to y square. X equals to y square, it looks like this. Let me get rid of this blue curve. X equals to y square. So x equals to y square looks like this. So now vertical lines are hitting it twice again. So again, not a function. So that's a vertical line test. So if you have a vertical line, it will pass through the function at most once. Okay. So this is a graph of how functions work. You give some input, the function gives you some output f of x. Sometimes it behaves like a mathematical formula. Sometimes it will not. Sometimes it will just give you some random thing you don't know. Okay, for example, income of any agent X. So income of an agent X is something which is very personal. It's not a mathematical formula of exact mathematical formula of your let's say of your age and your education. People with the same age, same upbringing, same education could have different wills. Two twin brothers could have different wills, different income levels. All right, so it's not an exact formula. So it could be something which is a formula. It might not be something which is a formula, but it will be a function because everybody has an income. Everybody has an income. The domain. So the domain is a set from which elements are taken as inputs for a function. So if we talk about, let's say, domain of Aadhaar card, the domain of Aadhaar card is all residents of India. Not an important topic for us, but Aadhaar is also issued to non-citizens. Like if a person from Nepal is working in India, they can get Aadhaar cards. Okay, they need Aadhaar cards because everything is now linked to Aadhaar cards. If you want a mobile phone, you need to have an Aadhaar card. So if they want to live in India, they need an Aadhaar card. So all residents of India, they get Aadhaar cards. So the set of all residents of India becomes the domain for a function. Okay. So now I want to find, let's say, domain of different functions. So suppose I want to find domain of a function 1 by x. So domain is, so the crucial thing to remember is that function has to be defined over the entire domain. If a function is not defined over some points in a set, we remove all such points from the set to get the domain of this function. So suppose I define a function f of x equals to 1 by x, where x can be real numbers, but x cannot be equal to 0. Because if x is equals to 0, denominator में 0 आ जाता है, and denominator में 0 is unacceptable. So the domain of this function will really be the set R minus 0, R set minus 0. Okay, you don't call it R set minus 0 because this is a subtraction of sets. So this is a set, so you should subtract a set from it. So like I told you, 0 is an element, this is a set. So you are subtracting the set 0 from R. You are not subtracting 0 from R. You are subtracting the set 0. Set 0 is not null set. Again, the set 0 is not equal to null set. This is a common rookie mistake. Null set is nothing, emptiness. Okay. What is null set? Null set is, this is null set. Nothing, blank. When I write 0, this is not a null set. This is an element which contains the element 0. Okay, a set which contains the element 0. So the domain is R set minus 0. Okay, so one of the problem sets that we will be doing this week is regarding this domain problems. It's called functions. So let me just give you a hint of how to do this. Let me take question number 2, for example. So I have to find domain of this thing. Copy this thing. So I have to find the domain of this thing. So first thing is that in the denominator, I should not get 0. But also in the under root, I should always have a positive. So there are certain rules which you need to obey. One thing is for under root k, k should be greater than or equal to 0. Second rule is for 1 by L, L should not equal to be 0. Okay. So if something is a denominator, it should not be 0. If something is inside under root, it should not be negative. And third thing is for log of m, m should be strictly greater than 0. So if you have logarithmic functions, log of something, the something should always be positive. So these are the 3 rules that you need to obey when you are solving these problems. So let me take this example, 7 minus under root x square minus 9 upon under root 25 minus x square. So this under root 25 minus x square implies that 25 minus x square should be strictly greater than equals to 0. But at the same time, this is on the denominator, so it should also not be equal to 0. So what I get is that basically 25 minus x square should be strictly positive, because equality to 0 will make the denominator 0, which is not acceptable. Okay, so these things are the rules which you need to follow. These 3 rules you'll have to follow for everything. So 25 minus x square has to be strictly positive, which means that x square should be strictly less than 25. Okay, now x square less than 25 means what? Which set satisfies this condition? Which set satisfies this condition?
X is between -5 and 5.
Very good. But can you specify the sets?
Open
Sorry, the
interval,
brackets.
open interval -5 to open interval 5.
Very good. X belongs to -5 to 5, open interval. Okay, because it's a strict inequality. It's not weak inequality. Had it been like this, then I would have had these sets. But since this is like this, the sets are going to be strictly open. Okay. The second thing is x square minus 9. So the second condition that I have is that x square minus 9 should be greater than equal to 0. Now I allow for equality with 0 because I no longer need this thing to be non-zero because it's in the numerator. So it can be 0. So x square minus 9 should be greater than equals to 0, which implies that x square should be greater than 9. So what set satisfies this condition? Anyone? Okay. How You actually, yeah. You
Closed
please go on.
closed
Yeah.
intervals -3, +3.
You're saying -3 to +3. So one of the elements here is 2. Between -3 and 3, one of the elements is 0. Is 0 square greater than 9? Do you want to change your answer, you actually?
So these elements will not be included then.
So what's
So it will
included?
be 0. It will be 3 closed intervals 3, infinity.
Just 3 to infinity? Nothing on the negative side?
So minus infinity to -3 closed union, close 3 to infinity open.
Very good. Okay, minus infinity to -3, union 3 to infinity. Okay, x square minus 9 means what? Mod x is greater than equal to 3. Mod x is greater than equals to √9, right? That's how you can go from here to here. So mod x greater than equals to √9. √9 is what? 3. So mod x greater than equals to 3 means what? So when you reach this point, you can maybe draw the graph. Okay, take as many steps required in the initial few days of solving these problems. Try to be correct. Don't try to be fast. That's the important thing. Okay, so you need to develop this habit of being accurate and not being too fixated on getting the answers fast. So this is your y equals to mod x curve. And you need mod x greater than 3, which is basically y greater than 3. So this is your point 3 minus 3. So when is mod x, which is when is mod x greater than 3? So it is greater than 3 in this region, which is 3 to infinity. It is greater than 3 in this region, which is negative infinity to -3. And then we'll have closed brackets because it's a weak inequality. All right. So this is, let's say, your set A. This is, let's say, your set B. Now, final answer. Let me ask this to let me throw this question to Ananya. Your final answer for this question, should it be A union B? Should it be A intersection B?
So it will be A union B. I think because it will be include element from both, like this set minus infinity to 3 union 3 to infinity, and from that to -5 to +5.
Okay, it's actually going to be A intersection B because I need both these conditions to be true. Why should it be A intersection B? Because this thing should also be true and this thing should also be true. Because if anything goes wrong, if A is satisfied but B is not satisfied, then this thing will become, the thing inside the under root will become negative. So that's not allowed. So I want both conditions to be satisfied. So if I want both conditions to be satisfied, it's going to be A intersection. So the final nail in the coffin is you just take the intersection of these two sets. Okay. So final question to Anuradha. What is the intersection of these two sets? Write it down, Anuradha.
Sir-
Don't give me the correct answer again. Okay, give me the correct answer, not the fast answer. Tell me.
So open -5 to close -3.
Hmm.
Intersection 3 to 5. Close 3 to open 5.
Okay, so this is not going to be an intersection. This is going to be a union. Okay, because the intersection of these two sets is a null set. These are two different sets separated in space. If you take the intersection of them, it's going to be a null set. So the way to do this would be on a number line, you just plot these sets. That would be easier. Maybe have pens of different colors if it helps you. Helps me, but then I have all this setup in which I can draw as many colors as I want. So set A would be -5 to 5. Right? This is -5, this is 5. So this is my set A here. And my set B is set B is this one, negative infinity to -3. and 3. So set B is this thing. So intersection means what? A intersection B means what? This is my set A and this downward thing is my set B. A intersection B means the points on the real line where both the colors are existing. Right, so that's going to be this region. So that is -5 to -3. I can look at the brackets here and see if -5. So if I'm unsure about the brackets, I have to see if -5 is included in both. If both sets include -5, I will include -5. If any of the sets does not include -5, I'll have to exclude -5. So I'll go back to these sets. So set A does not include -5. So I should not include -5. Now, if I look at -3, -3 is included here, -3 is included here. So I will have closed -3. Now, union of again 3 to 5 by same logic. So the union just tells me कि ये points है and ये points. If I take an intersection here, the intersection of these two sets will be null set. So that's why I don't take an intersection. Okay.
Okay,
So I
sir.
take intersection between A and B, and that intersection set is defined as this union. Okay, so this is basically A intersection. Okay, so these are some things which you need to keep in mind when you are doing these problems. So let me come back to this problem set. When you do any problem from this set, just make sure you proceed in a very orderly manner. For example, in this question, the denominator has to be non-zero. Okay, so first you draw conditions for this thing to be non-zero. Okay, so first you need conditions for this thing to be non-zero. Sorry, this thing to be non-zero because it's a denominator here. Then this entire thing should be non-zero, and finally this entire thing should also be non-zero. So you get condition 1, condition 2, condition 3, and then you take the intersection of these 3 conditions. So you draw sets for each of them, and then you find the intersection of these sets. Okay, so it's going to be cumbersome. It's going to take some time. I just want you to do till question number 13. That will be sufficient. Okay, no need to go beyond question number 13. Till question number 13 is sufficient. All right. So that's about the domain, finding domain. It's an important part, important exercise for you. The other part is codomain and range. So the range is that part of the codomain which is active. Okay, so suppose I draw the function f of x equals to x squared going from R to R. So suppose I define function from R to R as f of x equals to x squared. So the codomain is -infinity to infinity because it's the entire real number line. But the range of this function, x square values will always be greater than equals to 0. So the range is the actual values which f of x produces. So the range is just going to be 0 to infinity. So the range is always a subset of codomain. Okay, so sometimes the question might ask you to find the range of any problem. We'll do questions on range, but we'll do it very later on because finding the range of a function is very difficult. You need to find out its maxima, minima, find out discontinuity, stuff like that. So at the end of this entire real analysis bed, in the very fag end thing, we'll have this problem set on curve sketching. So in this problem set, we'll be doing these things. So I'll be giving you some function and I'll be asking with the range of it. Okay, I'll be asking which maxima, minima. And by means of all that, what we'll be doing is we'll be drawing the entire curves. So right now, you cannot draw the entire curve. Okay, right now you do not have the, if I just give you this function and ask you to draw the curve, you don't know how to draw the curve. It's not possible right now. So it will require us to reach there. To be able to reach there will take us about 2 months of time, 1.5 to 2 months of time to reach there. Okay, because we are doing 1 lecture per week and some of the lectures are going to be more than just 1 session. So it's going to take us another 1.5 months to reach the 6th chapter of derivatives. But when you reach there, this will be the one of the most interesting problem sets. And when we do that, you'll feel very confident about your functions, because then you know, because a graph of a function is its Janma Kundli. Okay, you can know everything there is to know about the function if you can know its graph. Okay, but long way to go till there. Just giving you an idea that how much where we have right, yeah, we are right now and where we want to reach is going to be a very long road. So range we'll do later on, but the range of a function f is defined as all values in the codomain such that it is mapped for some x. Some x is taking that value. Some x should be taking that value. Okay. So x square takes non-negative values, so we can remove all the functions. So you can define the function x square as r2r, or you can define that function as r2r plus. So technically, when you define this function as this or this, the idea is you're just removing some parts on the y-axis. You're saying, what you're basically saying is that when I'm drawing the curve, of y equals to x square, I can either draw it like this, or I can draw it like this. I'm removing the negative parts of y-axis because it is redundant. I'm saying the negative part mein ja hi nahi raha hai, so why do I draw it? So that's the difference. Here I am defining my function as r2r. Here I am defining my function as r2r plus. I'm removing the negative part of y-axis. So technically it's remained the same, but since you have changed the codomain, here the codomain was r, here the codomain is r plus. We say that these are different functions. So you call this function f, you call this function g. For all practical purposes, they are same function. They are the same function. But the convention is, if you change anything, you call it a different function. I mean, it's a convention. Okay, you want to follow it, you follow it. You don't want to follow it, no harm done. All right, next thing is one-to-one and onto functions. So a function is onto or surjection. I want to reach where I want to reach composition and inverse functions. Okay. Onto functions is if the range is the codomain. Okay. So so this is the example of a function that is not onto. Why is it not onto? Because this point is not mapped by any element in A. So such a function from A to B is not onto. Okay, because some elements in B are not being mapped. So I think you guys would have already done it. I'm just going to revise this part quickly. One-to-one function. A one-to-one function is something like this. This is one-to-one. Okay, this is one-to-one. Let me just highlight which are one-to-one. This is not even a function because A is being mapped with two values. So this is not a function at all. This is not one-to-one because two elements are giving the same output. So it is possible for a function to be a function. This is a function, but not one-to-one. Okay, two people can have the same mother. Okay, two people can have the same mother. So that is not a problem. Still a function. This function is one-to-one. It is not onto, but this is one-to-one. Because every element has a distinct output. Every element input has a distinct output. Okay, this is a function, but not one-to-one because these two elements have the same output. Okay, and this is again one-to-one. Okay, this is one-to-one because every element has a different output. The outputs are different. So that's one-to-one, and the first thing we did was onto. Now, if a function is one-to-one and onto, it's called a bijection. A bijection is one-to-one and onto functions. So it must be one-to-one and it must be onto. So this function is both one-to-one and onto. So this is a bijection. Okay, this is onto but not one-to-one. Okay, so this is called surjective. This is one-to-one but not onto, so this is called injective. So these definitions you need to remember. They are, I don't know why they have given some so confusing names. I keep on forgetting them. Okay, but you are giving the exam, I'm not. So it's okay if I forget it, because I did my bit. Okay, you can't blame finger. Okay, I gave my exams, I cleared them. It's now your turn. Okay, so you remember these things, because a lot of exams they just give you that the function is surjective or the function is injective, and if you don't remember what is injective or what is surjective at that point of time, you could be in a big trouble. So just remember that injective is one-to-one, surjective is onto, and bijective is onto and one-to-one. Okay, it is both onto and one. Okay, so do this example. I will talk about this in the next class. Think about one-to-one and onto functions. Think about it. Okay, don't do the range bit. Don't do the range bit. Right? Just do the domain bit for this course. Okay, one final topic for today quickly. It's going to be composition and inverse functions. Because the problem set has some questions from this, so I want to take care of this. The composition of function is it's very simple. What is composition? So there's some function which takes values from set X into values from set Y, and there's another function which takes value from set Y into value from Z. Okay, so you start with from X, go to Y, from Y you go to Z. So suppose you have the Nani function. The Nani function gives the Nani of any person X. So what it does is it finds your mother and then it finds your mother's mother. Okay, so it applies the rule twice only. Okay, or you could have the Dada function. Sorry, the Nana function. Nana function is better order. Nana function is basically father of Nana of any person X is father of mother of X. So you find any person X, you find that person's mother, and for that mother you find her father. So the father of the mother is the Nana. So the function Nana is just a composition of father and mother functions. Okay. On the other hand, the Dadi function is mother of father of X. So the order in which these functions operate becomes very important. Okay, so mother of father is Dadi, but father of mother is Nana. They are different outputs. For the same person X, Dadi and Nana are different people. So in what order the functions operate becomes important. Okay, so for example, let's say f of x equals to x plus 2 and g of x equals to x squared. Okay, so f of g of 3 is basically f of what is g of 3? G of 3 is 3 square. So this is f of 9. Now what is f of 9? This is 11. On the other hand, g of f of 3 is g of what is f of 3? F of 3, you just put 3 here. So it's going to be 5, right? And what is g of 5? G of 5 is 25. This is 11. So f of g of 3 is 11, whereas g of f of 3 is 25. Now, g of f of x can also be written as g of f of x. G of f of x. And f of g of x can be written as f of g of x. These are different things. So that's composition. Okay, so composition is one function or one other function. So it gives you a final output. So f of g of x just gives you the final output of this guy. So if you want to find the nana of any person x, you can either find the mother and then find the mother's father, or you can directly generate a new function and directly go from this person x to the nana of x. So it does the job of finding the nana in one single calculation instead of two calculations. So that's the importance of composition. Okay. But the thing in composition is, let's say you're going from set A to B and then B to C. All right. So the thing to keep in mind is that when you're doing this sort of calculations, let's say the entire set B is the range of function f. So function f is mapping this entire B. But for the set G, these points are not in the domain. Not in domain of G for some reason. Then what will happen is you have to eliminate these points from the study. So that's one thing. But not to worry about much, because the domain of composition functions and all those things are too complicated for our level. We are not going to ask. For simple functions, you should be able to calculate the domain. But for compositions, domain and ranges, these are things which are too far-fetched. It's not that it's not in the syllabus, it's that they don't ask. I want you to be well versed with finding the domain of just functions. Composite functions, the domains and all those things. We need not go into so much depth in maths. We are not doing an engineering course. We don't want too much depth. We want to cover a lot of breadth, but we don't want the बहुत ज़्यादा अंदर घुस के ask you questions. That's not going to be relevant. But I've given you an example here, so you can go through this example about what I mean. So the domain of g of f and f of g. So both these domains I have asked you to calculate. All right, and one final thing is inverse. So go through these examples. And one final thing is inverse functions. So function f takes from x to y, f inverse will take from y to x. Okay. So it will just take 2-3 extra minutes. So just be patient. Stay with me. So this is your set x and this is your set y. So you have a function f which goes from set x to y. Now, if this function is a bijection, if it is a bijection means it is one-to-one anon. So if f is a bijection, you can even go in the reverse direction. You can call this function as f inverse. Okay, so suppose f of x is x plus 3, and somebody asks you find f inverse of x. So f inverse is something which takes you return. Okay. So how do you find this? So you write this function as y equals to x plus 3. Then you rearrange this. So now you have y as a function of x. What you want is x as a function of y. So you call this as x equals to y minus 3. And then you replace y and x. So you call finally x and y could just interchange. So y equals to x minus 3. And then you say that f inverse of x equals to x minus 3. So this is how you report f inverse. This is how you find f inverse. Okay, you start with f of x equals to x plus 3. You call f of x as y. Then you rearrange. After rearrange, you just rename x as y and x, and then you report. Okay, so f of 2 is 2 plus 3, which is equal to 5. Now f inverse of 5 should be equal to. So let us check if f inverse of 5 is giving me 2. F inverse of 5 will be equal to 5 minus 3. According to this formula, it will be 5 minus 3. So that will be equal to. So f inverse of 5 is 2. So this works. F of 2 is 5 and f inverse of 5 is 2. Okay, so f of 2 is equals to 5. Okay, so f inverse of so 2 should be equal to f inverse of 5. So this is how you can find the formula for f inverse. Now you can only find the formula for f inverse if the function f is 1 to 1 and 1. Okay, so this function is 1 to 1 and 1 to. X plus 3 is 1 to 1 and 1 to. If I give you f of x equals to x square, this is not 1 to 1 and this is not count. So so we cannot find its uh, inverse. You cannot find its inverse. So f inverse does not exist. So what did mathematicians do? So instead of defining this function as r to r, what they defined it as r plus to r plus. So x is only non-negative values, y is also only non-negative values. And then they said that now x and y is defined. So what happened is that x square is ideally defined on the entire Cartesian plane. They said, no, we won't do this. What we'll do is we'll stick to just first quadrant. Now in the first quadrant, x square looks like this. And now it's a 1-to-1 and onto function. It's 1-to-1 because for any x, for any y, you are getting a unique x. So it's 1-to-1. It's onto because every x is now, every y is now mapped. Every y has at least one element which is being reported. So when they define this as r plus to r plus, this function becomes a bijection. And then they go on to define its inverse, and this f inverse of x was then defined as under root of x. But again, since f is defined from r plus to r plus, this root x was also defined from r plus to r plus. What it means is that the input can only be positive, which is obvious, but the output also can only be positive. And that's why this root x only gives positive outputs, because if not, then what happened was that this thing would have been r. So if this thing were r to r plus, then this function would not have been 1-to-1. So what happened is, if the all x values are allowed, then this function looks like this. So multiple x values give the same y value. So it's not 1-to-1. So if you define the function like this is not 1-to-1. So that's why to get rid of this, they defined this function x square as r plus to r plus. So only when x square is defined on r plus to r plus, the inverse exists and it is root x. Otherwise, the inverse does not exist. Okay. All right. So with that said, let's end this class here. Okay. Let me take a doubt session maybe Tuesday for the test doubts from the test which I shared. I hope all of you attempted it. If you did not attempt it, please let me know. I will give you an extension. Or if you want to attempt it again, even in that case, I can do it. So do the test. We can take a doubt session on that, as well as the problems from the first inequalities, if you have any other. Okay. All right. So we are a little over time, but at least we were able to complete this thing. Not much of this chapter remains. I think we have indexing and countable and countable. So this will be a little complicated topic, but these topics, you can start doing these things. Okay, you can start doing these problems, because later on, if you keep it for later on, you see it's a very popular topic. There are a lot of problems here. There's easily 30-40 problems from past days. So you can start with them. Some of them are going to be things that you cannot do because they might come from countable and uncountable sets. So if you feel like you are unable to do them, leave them for now. At least the ones you know you can handle. Okay, like this one, f of x. So you know you have to do the operation twice. So first f of x, then take that output as input for f of x again. So f of x. Okay, so do these questions as many as you can. Just start with it so that you don't have a lot of burden later on. All right. So I'll see you guys tomorrow, 4 o'clock, with the economics bit. There was a problem set which I gave you for not many problems, just 7, 8 different problems for min-max questions. So make sure you revise them, and I'll take doubts tomorrow for this. We'll discuss. All right. So I'll see you guys tomorrow, same time. Bye. Ending the class now.
Thank you, sir.
Welcome. Welcome.